Hi, we're going to be talking about the chapter 7 of Big Java early objects. And we're talking about some special topics for the arrays that would you start with the sorting arrays. So there are situations that we need to have our array sorted, either ascending or descending. There are a few reasons that we want to do it. One of them is if our array is going to be sorted, then our searching is going to be much easier. So let's say I have a long array of 10,000 elements and it's sorted with alphabetic order. So if I do linear search, that means I'm going to be looking for something from the beginning to the end. So the worst scenario is going to be the last one that I find it. The best scenario is going to be the first one. So generally, linear search is going to cost me about half of my size of the array to find something. So maximum plus minimum divided by 2. Now, if I sort it, if my array is sorted, I can at least stop somewhere if I know that what I'm looking for is not there. For example, if it's lots of name and I have sorted in ascending order, and I'm looking for a name with A, starting A, as soon as I pass and I get a name starting with B, I know the one that I'm looking for is not there anymore, so I don't have to go through the whole array. So I just stop right there. That's a minimum. Of course, there are some other algorithms that we're going to be talking about the searching and finding those things. There are different algorithms of how to sort arrays, and they are different ones that we can apply and use it. But on the other side of it, Java already providing a sort method. So I can just call arrays.sort and pass my array here, and it's going to sort it. Of course, if our array is going to contain object, we're going to get into more detail on it. I need to have overloaded greater than, less than to be able to sort it. We're going to get to that later on. So if it's partially filled, I can put the starting and ending in there too. So if I don't say anything, it's going to go from the beginning to the end. If I put numbers in there, it's going to start from this number and ends with this number. One less than that. Inclusive, exclusive. So as I was saying, that if we do the sorting, then we can have searches that's going to make it easier to follow. Now, you have to understand that if you're using arrays and it's sorted, we talked about this earlier, that insertion and deletion is going to cost us some time. Because if I remove, let's say that I have a 10,000 elements in my array and it is sorted, and I want to remove elements number 2. That means I have to push everything from that point to 10,000 back. The other way around it is if I want to insert something in element 2. That means I have to push everything back. Remember, arrays are set. So if I want to insert something in element 2, I have to move everything to the right. If I delete, I have to move everything to the left to fill it in. So those are the costs. And when you get to your software engineering, you're going to sit down and figure out what's the cost versus the usage of it. So if I don't have too many insertion and deletion, and I'm doing a lot of searches, then that would be a good algorithm to use. But if I have a lot of insertion and deletion, then maybe that would not be a good one. And you talk about more of this in your software engineering class. So a linear search is going to start from the beginning and it's going to go all the way to the end. And of course, if it's sorted, then I can stop. I can check to see and a location that I can stop, so I don't have to go through all of it. There is another one, it's called binary search. So some of you might have come from or C++ classes that you took these ones, the binary search. So the idea of the binary search is you would start, so we're looking for something. So we go to the middle, and if we can find it, good. If we cannot find it, we can choose to go to the left or go to the right. So if what I'm looking for is smaller than the element that I have, I'll go to the left. If it's larger, I'll go to the right. And I repeat the same thing. So this is the place that the recursion is going to come to play, and it's going to be helpful here. Of course, we can do it in the loop also. So in this case, I am looking for 15. So I go in the middle, I'm looking at that one. So I know it's going to be above 12. So I go and then I cut it in half. I know it's less than 17. And then I cut it in half, and then I know it doesn't exist. So the example of that one to do, of course, we can do this through recursion. When we get to the chapter recursion, we're going to do the same thing in recursion. But just to use the loop, we're going to start with the low from the beginning. And then we have the position that we're going to start it. And then the high is going to be at the end. So we start from the beginning to the end. And then as far as the low is less than or equal high, remember what we're going to do with this, our low is going to the right or left, high is going to go to the left, and somewhere they may cross each other. And if they cross each other, we know we didn't find what we're looking for. So we're going to add those things up, and we're going to divide by 2. We're going to find the midpoint. And then we are going to that one, to the midpoint. If we found it, then we're done. If we don't find it, we got to see if what we're looking for is greater than, or if that's the case, if what we're looking for is greater than what we have in an array, that means I have to go to the right. My high, which is the end of the arrays, is going to stay there. My low from 0 is going to come to the current position plus 1. And the other way around, if I have something that's going to be smaller than what I'm looking for, then I'm going to go the other way around. So I'm going to check the position. The high is going to be position minus 1. So remember, when I'm starting, my low is here, my high is right here. Now, if what I'm looking for, so I'm going to go to the midpoint. If what I'm looking for is going to be greater than what I have, then I'm going to move my low right here. If what I'm looking for is less than what I'm looking for, I'm going to move my high here. That's what we do. And if we go cross each other, then we know that we didn't find it. I'm going to stop right here. I'm going to make another video for the arrays with the method. So I'm going to just stop right here.